Hello, ladies and gentlemen. Welcome back to Physics 20, Waves, Lesson 3, Reflection Interference Student Notes, Part 2. Now, I'm hoping you took a look at that applet thing. Not the most interesting, but it actually shows nicely reflection. Now, waves in a spring or string reflect. So when a crest is incident, that is, hits a fixed boundary, it reflects and inverts as a trough. So if you have a line, so if this is your string, or spring. Now, if you're here for the first lesson when we did the waves, you know, you make a pulse and it goes like this and it travels down the line. If this is fixed, it will bounce back as a trough. All right? Now, on the other hand, if you have a crest going down and this end can flop up and down like a whip, it will reflect back as a crest. Now that was a bad drawing because the crest doesn't get bigger. It should be the same size, or actually because of friction it probably could be a little smaller. But it will reflect as a crest. So when a crest hits a fixed boundary, it inverts as a trough. When a crest hits a unfixed or open boundary, it reflects as a crest. Trivial little point. Yes, is there going to be a quiz question on it? I don't think so. I can't remember. Anyway, it's one of those little things I got to mention, so be prepared to see one quiz question on it, okay? Now, of course, this begs the question, what happens when we send two crests at each other? Make this nice pink. At each other. Two troughs, a crest and a trough. Now, there's this second applet here from Germany, Walter Fendel, Deutschland. Standing waves reflection. It kind of sucks too. Well, sorry. It's not nearly as much fun as being in class and playing with the 15-foot long spring, but you're watching this video at home because you can't be in class. So go to this app, pause the recording, go to this app, play with it for a couple minutes, we'll come back and talk about it. So if you haven't played with the springs, regardless, pause the video, watch this. I don't know how to pause it, so I'm just going to keep on going, assuming you've got a pause button. Now, as some groups saw earlier with our spring lab, when two crests or two troughs meet, they add up, creating one large pulse. This is called constructive interference. Constructive interference. You see this, the two crests coming at each other, making one larger one, and then they part and they keep on going. Now, this is constructive interference. The overlap of waves to create one wave with a larger amplitude. Okay, larger amplitude, larger height, bigger wave. Physics 20, high school science, we're going to use the fancy term amplitude. Okay? Now, similarly, when a crest and a trough overlap, the amplitudes are again added. However, this should result in a pulse of smaller or no amplitude. Sorry. Spell smaller correctly, Mr. Sutton. Or no amplitude being created. This is destructive interference. So you see the crest and the trough coming to each other and they cancel out. The magic of drawing it exactly the same. Now, when you guys did the spring lab a couple days ago, or if you've been away, you'll do it when you come back, you'll have partners trying to make a crest and a trough to cancel each other out. It takes practice, and you generally don't get complete canceling out because it's difficult. But this is destructive interference, the overlap of waves to create a pulse of smaller amplitude. So when you did the lab, you probably didn't get the crest and the trough the same size, but you're close, and they would have partially canceled out. Now, the resulting pattern is called a standing wave. A standing wave appears to oscillate or bounce around a set of points called nodes. Now, standing wave appears to oscillate, that is, vibrate around a set of points called nodes. So, if you're in class, I'm demonstrating this now. We have the antinode, the blue one's in the middle. Now, wrong color, sorry. So antinode are the high and low points in the middle. Now, this is going to be maximum energy, maximum displacement. So the regions of maximum displacement are called antinodes. All right? So that's important. Okay. Maximum displacement are called antinodes. Do I have a purpley one? I do. So the node where there's no displacement, where the waves cancel out. Okay, now this is important. Now, I also want to mention a couple of things here. This here, what have we got here? One complete wave. So the length of the string is the wavelength. All right? So far, so good. Now, note up here, this string is half a wave. The length is 1/2 the wave. And we come down here, we have 1.5 waves here. But this length is 2/3 the wavelength. So 2/3 of that length is the wavelength. Okay, now this is important, or it becomes important, because here, if you've ever played musical instruments, you pluck the guitar or the violin or the banjo or whatever, you will always get this half a wave. This is so often, it's called the first or fundamental frequency. Now, I used to bring in a guitar and I tried plucking it. I could always get this half a wave. I could never get this full wave here. It was annoying because I'd ask the music teacher to come in, and my previous school, she'd just pluck it and she'd get the whole wave going. Now, this is called the second frequency. Oh, sorry, I should. Now, I want to spend a minute on this because this fundamental or second, here, 3 waves, or 3/2 a wave, you'll get what we call the third frequency. Guess what? There's a 4th and a 5th and a 6th. And I'm just jealous because the art teacher at my previous school, a music teacher, she could just pluck it and get the third frequency, no problem. And I could never. Anyway, if you're in class right now, I'm playing with the 5-meter long spring, and I'm showing you this. All right? So note this, the first, second, third frequency. Okay? Now, yes, I'm going to pause recording here because it's getting kind of long. We're going to go on. Oh, actually, you guys can go to this website here, and they'll do this standing wave reflection app. So go play with that, pause, finish the recording, go to this website, play with that app, come back, and we'll finish the notes, okay? Any questions, shoot me an email. Otherwise, good luck.